Okay, here we have another conic section. This is an ellipse. Okay, we know what's an ellipse because there's a plus in between these two squared things. Okay, there's these numbers on the bottom. I guess they're different, which is important, them being different, and it equals 1. So this is the standard form of an ellipse conic section. So there's a couple of things we can get immediately from this. We can figure out where the center of this ellipse is simply by looking in your parentheses. So we have a -4 in parentheses, so it's going to be a +4 when it comes out. And we have a +2 in parentheses, so that's going to be a -2 when it comes out as your center. Okay, the x-coordinate is always with the x parenthesis, and the y-coordinate is always with the y parenthesis. Now, if there's no parentheses, then that coordinate's going to be 0. Okay, so now we need to look at something else, and that's the numbers underneath. So we have 9 underneath the x. So we're going to go in the x distance, okay, from your center, the square root of 9, in other words, 3 in every direction, left and right. Okay, and then we look at what's the number underneath the y, and we're like, oh, that's a 25, so we know that you have to go 5 units, which is the square root of 25, in the y direction. Okay, so in this case, because y is bigger, this is going to be part of your major axis, or your major length, and because the x1 is smaller, this is going to be your minor axis along the x-axis. So what we do is you have some axes, of course. So let me squish over a little bit so I can see these. 4, -2, so let's make it over here. Okay, 1, 2, 3, 4, 1, 2. This is where your center is. Okay, and then we're going to go, let's see, 3 units in the x direction. So we go 3 units left, 1, 2, 3, 3 units right, 1, 2, 3. Okay, so this has a minor axis length of 6 units, just so we know. Okay, because 3 plus 3 is 6. Okay, the axis length is always twice as much as this number here. And then in the y direction, we're going to go 5 units, 1, 2, 3, 4, 5 up, and 1, 2, 3, 4, 5 down. Okay, so here are your minor. Your major axis is going to be 10 units long, and for your major axis, because that is the longer one. Okay, so it doesn't matter which one is A and which one is B, per se. What matters is which one is bigger. The bigger one is always the major, and the smaller one is always the minor. So now that we know this, you can do your best to make it as ovalish or as elliptical looking as possible. Okay, it might not always end up looking funny, but that's okay. I don't judge the pictures, just the math. So there we have our ellipse. Now the last thing to do is figure out where our focal points are. So for the focal point, f squared equals the larger one squared. In this case, it's 25. Well, 5 squared minus 3 squared. Okay, it's always the bigger one minus the smaller one. So 25 minus 9 is 16. So the focal length is 4 units away along your major axis. So 4 units from your center, 1, 2, 3, 4. Here we have a focal point there. And 1, 2, 3, 4. Here we have a focal point there. Okay, so the foci are the last things that we're going to sketch whenever we're doing an ellipse. And for an ellipse, it's always a subtraction problem. The larger number on the bottom minus the smaller number on the bottom. Okay, that way it's always positive, it's always real, and it's always inside of your ellipse.